Okay, this is number 28 and the last example that I will do in section 5.3. Very similar to number 22, except we have a 3 by 3 matrix here, where A is our coefficient 3 by 3 matrix. And notice the form. We have x, that's bar really, x prime equals ax. Right, so this is very powerful. X prime equals ax. And again, every single letter here is bold, so there's no need to write the bars unless you want to. It's only when you have bold letters and some unbold letters. Okay, so let's begin here. So the first one, I think I wrote number 1. No, I didn't. So our first, we want to verify these solutions. So x prime equals ax, but I want to check the first solution, so it's going to be x1. Again, these are boldface. So again, left-hand side, I think I LHS, left-hand side, right-hand side. So what is my x1? Well, my x1 is 1, 6, negative 13, and if I take the derivative of that guy, well, there are no functions of t in this case, so my derivative is just the 0 matrix. Okay, so that's my left-hand side, and now my right-hand side is 8 times x1, so let me write my a out, and we have, okay, so we have a, so 1, 6, negative 1, 2, negative 1, negative 2, 1, 0, negative 1. And I'm going to multiply it by my x1, which is 1, 6, negative 13. Okay, so we have a 3 by 3 by a 3 by 1. So my result should be a 3 by 1. Okay, so we have, row times this column, row times column, row times column, we're using just the dot product, the product of the components, and then we're going to sum them up. So we have, if we multiply this, let's say we have 1 plus 12 minus 13. Next guy, 6, I'm doing this row times this column. So I have 6 minus 6 plus 0. Finally, this row times, well, the only column we have, minus 1 minus 12 plus 13. And, well, this is obviously 13 minus 13, 0, 0, negative 13 plus 13 is 0. So we get the 0 matrix. Therefore, our left-hand side does equal our right-hand side. And so there's 3 solutions, so you have to check the second and the third one. But again, it's very, well, let me actually do x2 and then I'll leave x3 for you, since we do have a function of t here. So I'm going to check x2. So the next part is, so I want to verify, okay, so this first one, that was verify that guy. So now I want to verify x2 prime equals ax2. Okay, so what is x2? And let me actually, so again, LHS, left-hand side, right-hand side, and they should match up. And I have x2, which is, and notice, okay, so I have e to the 3t times this vector, but I can multiply that function in, so I'm just going to write it as 2e to the 3t, 3e to the 3t, and negative 2e to the 3t, because I want to take the derivative of that, and that's just going to give me, this is nice, this is going to give me 6e to the 3t, and I'm going to get 9e to the 3t, negative 6e to the 3t. Okay, so there's my left-hand side. Okay, let's do the right-hand side. And we have, again, our matrix, our coefficient matrix, A. So 1, 2, 1, 6, negative 1, 0, negative 1, negative 2, negative 1. Let me move this up a little bit. And our x2, right? So a x2, again, these are boldface. And we have 2e to the 3t, 3e to the 3t, and negative 2e to the 3t. So again, we have a 3 by 3, and we're multiplying it by a 3 by 1, and so we should have a 3 by 1, and in fact, right, we should get this guy because we're verifying. Okay, so let's multiply this guy out. So this is going to be 2e to the 3t plus 6e to the 3t minus 2e to the 3t. And I mean, we can even check here. Is that going to give us 6e 3t? And yeah, these guys are gone. So we do get, well, that's the first row. And the next guy, so we're going to do row times column. And we have, let's see, 12e to the 3t minus 3e to the 3t, and then 0, I guess if you want to write 0. And this guy does give us 9, right? 9e to the 3t, so that checks out. And finally, right, we have this guy and this guy. And we have minus 2e to the 3t minus 6e to the 3t minus 2e to the 3t. And let's see, I'm supposed to get negative 6. And let's see, maybe have a positive. Let's see, did I multiply it right? Negative, negative, and the last one actually should be positive. Okay, so there we go. So it checks out. This is equal to the right-hand side. So we verified solution 1 and solution 2, and I'll let you guys do again solution 3. Okay, so the second part is let's find the Wronskian of the matrix. So 2, and the goal is to show that the Wronskian is non-zero in order to prove that these solutions are linearly independent. So we have W of t, which is going to be our 3 by 3, and our solutions are going to be let's see, 1, 6, negative 13. Okay, so, whoops, make that a little bit smaller. 1, 6, negative 13. And the next one, let's see, a different color maybe. The next solution with the function t is going to be, alright, I'm looking at this guy. So, e to 3t, 2, 3, negative 2. So 2, 3, negative 2, 2, 3, negative 2, but they all have a e to the 3t, e to the 3t, because we're multiplying that in. And then finally, let's make this one green. Our x3 is, so e to the negative 4t, and we have negative 1, 2, 1, negative 1, 2, 1, negative 1, 2, 1, e to the negative 4t, e to the negative 4t, and technically, I mean, we can erase that 1. I mean, you could leave it there if you'd like. So the goal is to find the matrix, the determinant of this matrix, and actually, I will, let's see, I'm getting to 9, I'm at 9:13, so I will stop here and continue in the next video.